So let's start with vector A, which is 20j, plus vector B, which is 40 cosine 45 degrees I, plus 40 sine 45 degrees j, and finally vector C, plus, let's see if I can continue below here, 30 cosine 45 degrees I, minus 30 sine 45 degrees j. So all we have to do now is add up our components. Now we can't add up i's to j's, we have to keep them separately. We have to add them up separately. So the first thing we're gonna do is that we're gonna add up all the i's, which I'm gonna highlight here. So that's my first I, and that is my second I. So when we add those two up, we should get, actually let's calculate them first. So 40 cosine 45 degrees is gonna give us 28.28 I, plus 30 cosine 45 is gonna give me 21.21 I. And now what's left for us here is are the j's. So here is one, here is another, and here is my third j. So the 20j, we don't need to do anything to it because it's already in form, plus 40 sine 45 gives us 28.28 j, minus the last one, which is 30 sine 45, which is going to give us minus 21.21 j. Alrighty, so now we just have to take our calculator and add all of those up, and we should get 49, that's for the I, 49 I, plus, and once we add up all the j's, we should get 27.07 j. And that concludes the first part of question A, which asked us to find the resultant in unit vector notation. So we've basically done everything they've asked for. Now here's our resultant, and here it is in unit vector notation. That is, it's written in both its I and j component. Now for part B, they ask for, what do they ask? They want to find the magnitude and the direction of the resultant displacement. So this is our resultant vector over here, and the first thing we have to get two things. We have to get the magnitude, and the second we have to get the direction of that vector. The magnitude is relatively simple. All we have to do is take the magnitude of r, which is our resultant vector over here. And notice that I have to again include the absolute signs to denote that I'm dealing with the magnitude of a vector over here. Now what is the formula for the magnitude of a vector? It's given by rx plus ry squared. You have to square each one of them, and then you put a radical sign over it. So what is rx and ry? If we were to look at our vector r over here, it would be made up of the following. It would be made up of rx, which is really the 49.49 over here, plus, actually what I should give it a direction, so it should be rxi. Let's write that. I plus Ry j. So our Rx here is 49.49 and our Ry is 27.07. So we're only dealing with the magnitudes of these components, right? So this whole thing is called a component because it includes the magnitude, which is the number, and the direction, which is the I. But when we want to get the magnitude of a vector, we're only concerned about its magnitudes, that is the Rx and the Ry. So when we substitute for this equation over here, we're gonna put 49.49 squared plus 27.07 squared, and then we take the square root of this whole number. And once we calculate that, we should get the magnitude to equal. Oh yes, also notice that I did not include I and j here. Sometimes students think that they have to say 49.49 I and then square all of it. That's not necessary because we're only dealing here with magnitude, so we don't really care about i's and j's because those are for the direction. So once we square those two, add them up, and then take the square root of them, we should get 56.41. So 56.41 units. So that basically makes up our the magnitude of our resultant vector, which is the first part. Now the second part they want is the direction. Now what are they talking about when they mention the direction? If we were to do this the old-fashioned way of, I'm talking about adding up the vectors over here, we would have to add vector A, B, and C head to tail. And to kind of show you what I'm talking about here, so if we were to draw a little Cartesian plane over here, and let's say we want to draw all our vectors. So I'm gonna draw vector A, so that's vector A, and if we're gonna place them head to tail, so I'm gonna keep vector A where it is. I'm gonna slide up vector B up here so that it goes in this direction like so. So I'm gonna add it up here, so that's vector B. And vector C, if we use a different color, we're gonna move that from it being here to here. So the red vector over here is vector C. That's what all we did was just slide it upwards so it meets. And sorry, this shouldn't be green, so I'm gonna draw vector C here. Now when I add up all those vectors together, I'm gonna get my resultant vector, which is gonna go from here to here approximately. And the angle between the vector that I just drew, which is the purple one over here, is gonna be, we're gonna call it theta. Now let me just move that down here so we can look at it. Alrighty, so when they ask for the direction, what I really wanna know is what the angle theta is here. So this is my angle theta over here. So once I've added up my green vector, which is vector A, my vector B, vector C, and we get the resultant, we want to find out what theta is. Now if I was to take that little triangle over here and separate it, or actually I'm gonna draw it on top, that's okay. Now if I was to just sort of form a triangle here, so just to show you how that trigonometry is gonna work so we can find out theta. So if I was to extend this here, and extend that down here, you will notice that it has just formed a triangle. And fortunately for us, we already know what the j component of the resultant vector is and what the I component of the vector. So once again, this vector over here is our resultant vector, and it's made up of two components, the j component and the I components, and we've already figured that out over here. So we know what the components are that make it up. So we're gonna use tan because tan works for us. Reason being is that we have the opposite and the adjacent. So the formula for tan theta is opposite over adjacent. So that works best for us because we have both the opposite and the adjacent. So in this case, the opposite is the same thing. So this is our angle theta, and the side that is directly opposite to it is the j side. Now in magnitude only, not in direction. How big is j? Well, j is 27.07, as we can see over here. So we're going to write 27.07 divided by the adjacent side, which is the side that is directly adjacent to theta, which is in this case the I side, which is 49.49. 49.49. So let's actually go ahead and calculate what this is equal to. So tan theta is equal to 0.547. So once you've divided 27.07 by 49.49, you're gonna get 0.547. And now all we have left is to bring tan to the other side over here. Now what is tan gonna become when it goes to the other side? It's gonna become tan inverse. Tan inverse of 0.547. And a little side note about tans. Tan inverse does not equal 1 over tan. Sometimes my students say, oh, in order for me to calculate theta, all I have to do is write 1 over 10 and then multiply that by 0.547. And that's not correct. I know that most students are used to, when they see the inverse sign over here, they automatically assume that it means 1 over whatever the number is, but that's not actually the case over here, because it's kind of an old notation. Oops. Here we go. It's an older notation, and for most other things, so let's say for x to the -1, yeah, it does mean 1 over x, but it just does not work for tan, sine, cosine, and all the other trigonometric terms. So don't make that mistake. So theta is equal to, so once you punch this in your calculator, you take the tan inverse of 0.547, you are gonna get 28.68 degrees. And once you've done that, you basically have gone the direction of the vector. So going back to our little diagram over here, this angle is exactly, let's pick some of them, is exactly 28.68 degrees. All right, so that basically completes the questions. They've asked us to find the magnitude, and we did, and they asked us to find the direction, and we did. So the theta angle 28.68 is simply the angle in degrees between the adjacent side and the resultant vector. And that completes this question, and I will see you in the next tutorial.